Hi to all, welcome to my class number 2 on chapter circles. Today I am going to discuss number of tangents from a point on a circle, inside the circle and outside the circle. And a theorem 2, the length of tangents drawn from an external point to a circle are equal, and exercise 10.2. Now let us go to the number of tangents from point inside, on and outside the circle. Take a circle and a point P inside this circle. How many tangents you can draw through P? Let us check. Here you can draw many lines passing through P. Now you check, will it intersect exactly one point on a circle? Here the lines which passing through P intersects 2 points on the circle. So there is no tangent through P to this circle. Now take the point P on the circle. Now let us check how many tangents you can draw through P which is on the circle. Let us check it. Here you can draw many lines, but only one line which touches exactly at one point on the circle. So through P, one and only one tangent you can draw. Now we can take a point outside the circle. Now the point is P. Let us check how many tangents you can draw through P to this circle. Here you can see exactly 2 tangents you can draw through the point outside the circle. So we can conclude case 1, there is no tangent to a circle passing through a point lying inside the circle. Case 2, there is one and only one tangent to a circle passing through a point lying on the circle. And the last case is there are exactly 2 tangents to a circle passing through a point outside the circle. Now let us consider the tangents from an external point. Here you can see tangents PA and PB are tangents from an external point. Now the length of the segment PA of the tangent from an external point P to the point of contact with the circle, we can call it as length of the tangent. So here PA and PB are the length of the tangents. So we can define length of the tangent as the length of the segment of the tangent from the external point P and the point of contact with the circle is called the length of the tangent from the point P to the circle. There is a property on length of the tangent from an external point. Let us see it. Here CF and CH are length of tangents and they are 6 units. Now when we change the position of C, you can see the length of tangents remains same. Here you can see the length of CH and CF, that is length of tangents. In all the cases they are equal. This is a theorem. Now, let us go to the theorem. Tangents from an external points are equal in length. The theorem is the length of tangents drawn from an external point to a circle are equal. Here we are given a circle with the center O and the tangents from an external point P to the circle are PQ and PR. This we can write first as a proof. Now what we required to prove here, next we can write, we are required to prove that PQ is equal to PR. To prove this, we need a small construction. We have to join OQ, OR and OP. So we can write, for this we join OP, OQ and OR. Now, what about angle OQP and ORP? You know that tangent is perpendicular to the radius through the point of contact. So we can write angle OQP is equal to angle ORP is equal to 90 degree. Reason, tangent is perpendicular to the radius to the point of contact. Now, in right triangles OQP and ORP, what about OQ and OR? Are they equal? Yes, they are the radii of this circle, so they are equal. So we can write OQ is equal to OR radii. Now one more side needs to prove these two triangles are congruent. What is the other side? Look at OP. You can see OP is common to both the triangles. So next we can write OP is equal to OP common. Now these two right triangles, one side and hypotenuse are equal. So we can say these two triangles are congruent by RHS congruence condition. So we can write triangle OQP is congruent to triangle ORP by RHS congruence. If two triangles are congruent, then we can say corresponding sides are equal. Therefore, we can write PQ is equal to PR. And the reason we can write this corresponding part of the congruent triangle, or shortly CPC. This is also an important theorem. Many times it is asked for CBSE examinations. So first, we took the circle with the center O, and PQ and PR are the tangents. Next, we have to prove PQ is equal to PR. For that, we join OQ, OR and OP. Now, these two angles OQP and ORP are right angle triangle because tangent is perpendicular to the radius. Now, in these two right triangles OQP and ORP, OQ is equal to OR radii, OP is equal to OP common. Therefore, triangle OQP and triangle ORP are congruent by RHS. Therefore, PQ is equal to PR by corresponding part of the congruent triangle. Now, let us look at the exercise questions. Look at the first question. From the point Q, the length of tangents to a circle is 24 centimeter and the distance Q from the center is 25. The radius of the circle. Look at the figure. Here, O is the center and Q is the point. Distance OQ is given as 25 and the distance QA is given as 24. You have to find out radius OA. You know that angle OAQ is 90 degree because radius and tangent is perpendicular. So consider this right angle triangle OAQ. OQ is the hypotenuse. So OQ square is equal to OA square plus AQ square. From this you can find out OA square and then OA. Do find it out. Now look at the question number 2. Figure is given. TP and TQ are the two tangents to a circle with center O. Angle POQ is equal to 110 degree. Then what is angle PTQ? Here you can see the radius and tangents are 90 degree. Now this will become a quadrilateral. ABCD is a quadrilateral. Angle D and angle B is 90 degree because tangent is perpendicular to the radius. Now the other two angles, sum of the other two angles must be 90 degree because in a quadrilateral total angle is equal to 360 degree. So two angles 90 plus 90 180 degree. So if the other two angles must be 180 degree. Here angle P and angle Q are 90 degree. Angle O is equal to 110 degree. So angle P should be 180 minus 110, that is 70. Now look at the next question. If tangents PA and PB from a point P to a circle with the center O are inclined each other at 80 degree, then what is angle POA equal to? Look at the figure. Here PA and PB are inclined at an angle 80 degree. You have to find out angle POA. This angle you have to find out. For that, you know, these two triangles are congruent, we prove. Therefore, angle OPA and OPB are equal to 40 degree. So this angle is equal to 90 degree. From angle sum property of the triangle, you can find out angle POA. The remaining questions we can discuss in the next class. That is all for today's class. Have a nice day.